Okay. Welcome to the third interaction session of Fundamentals of Electrical Engineering course in NPTEL. Before we start off with problems, I need to ask you a couple of questions. How many of you from here have attended the previous interaction session? That is the one that is happening today had happened today from 6 to 7. Is there anyone who has attended? Okay. If not, then
जी गुड मॉर्निंग मैम।
yes, Abdul. Did you attend the previous interaction session?
यस मैम यस।
Okay. Up to how much question have you guys solved?
आई हैव यस मैम। प्लीज एक्सप्लेन फंडामेंटल ऑफ इलेक्ट्रिकल इंजीनियरिंग फॉर वीक असाइनमेंट क्वेश्चन नंबर 5। वन सेकंड मैम।
Okay. Have you solved this question? Have you all solved this question?
यस मैम।
Okay. Then we'll
यस
start
मैम।
from we'll start from the next one then. Okay, you can mute yourself now. Okay, so let's dive into the problems. Uh, the question that is given here is uh, a circuit is given and it has a few branches in parallel and most of the branches are in parallel with each other, and you have to find this current ix, which is again there is a dependent voltage source which depends on this current ix. So what you have to either use KCL, KVL, or mesh analysis in order to compute this, right? Let me see if anyone is there. No. Okay. So first, can anyone suggest like how we are going to approach this problem? Anyone wants to suggest?
प्लीज एक्सप्लेन ऑल क्वेश्चन मैम।
Sorry, could you repeat that? Okay, maybe we'll start it off. So le- like it is like it has been said in the video by professor that whenever like most of the branches are in parallel with each other, it is easy to use KCL in this type of problems, right? So for this one we are going to use KCL. So this is one node, this is the second node, and this is the third node. We can apply KCL into these three nodes and try to figure out what is Ix. So let me just start it off. Sorry. Let us assume that like in this branch, this 12 ampere current is flowing, right? So let us assume that
जी मैम।
this particular branch I1 current is flowing, and in this branch ix is already given here, it is 18 ampere, right? So we can apply KCL in this node A. Try it out. Let me just admit what, if anyone is there. No. Okay. Then we can apply KCL at this node A. So the equation will be, let the voltage at this node A be VA, right? Let the voltage be VA, and at node B let it be VB and VC. Let us, we can also write it as V1, V2, V3, whatever it be it. V2, V3. Okay. So in order to find this Ix, what we need is, what will be Ix? If these are the node voltages given, Ix should be V1 minus V2 by 12, because current is flowing from here to this node, right? 1 to 2. So V1 voltage at node 1 minus voltage at 2 by the resistance between the two nodes. So Ix will be this. So in order to find Ix, what we need is to find voltage V1 and V2. How can we find that? We have three different nodes, and we can calculate equation according to it. Now, when we apply KCL at node 1, if we apply at 1, what we can find is, see, the 12 volt current is entering the node, 18 is coming out, I1 is coming out, and Ix is coming out. So by KCL we know 12 will be equal to I1 plus Ix plus 18. Now we can replace Ix in terms of V1 and V2, right? So if let can you start solving this equation now? So if we simplify this equation, it will be I1. What is I1? It is the voltage at no, I1 will be this voltage minus this. This is the reference. This is the common reference, right? So I1 will be V1 minus 0 by 4. So 12 minus 18, let's bring the 18 this side. So I1 will be V1 minus 0 by 4. And what will be Ix? We already have it here. Let's name this equation as 1. So from 1 we can have V1 minus V2 by 12. So if we simplify this, it will be,
Excuse me, ma'am.
yes.
How we taken I1 as V1 minus 0 by 4? Can you explain
Okay.
it?
Yes. So this node, let me use a different color. Uh, yeah. So this voltage is, we have taken this node voltage as V1, right? So we the node voltage means the voltage at the node with the reference. This voltage is equal to V1. So what is the voltage at reference? Since reference means what? The common ground. So at this node, voltage is 0 at this particular node. Similarly, here the voltage will be 0. Here the voltage will be 0, because this is a, like this is entire part of it is the super node, which is the reference node here. It is not the super node, it is the reference node. Like in all the in the entire nodes, see, if you look at this particular node, suppose A, B, C, these are all the same nodes because there is no element in between these two particular nodes. So they are all connected to each other, and it is grounded. So the voltage at A will be equal to 0. So what is, from the basic law we know, equal to V equal to IR, right? So here we are writing I is equal to V by R. Now resistance across this branch is given as 4 ohm. It is given here. And what is voltage? Voltage will be voltage at this particular node minus voltage at this particular node. So it is V1, since we have taken the voltage at node 1 as V1, minus 0, which is the ground, this reference node voltage, by the resistance 4 ohm, V by R. Is it clear?
Yes, ma'am. Clear, ma'am. Thank you, ma'am.
Okay. So let's move ahead with the problem. Now it is just a task of simplification. You guys can do this. So it will be like minus 6 equal to v1 by 4 plus v1 minus v2 by 4. Sorry, by 12. So if we take an LCM, it is 3v1 plus v1 minus v2 by 12 equal to minus 6. So just simplify this. In the meantime, let me see if anyone is in the waiting room. No? Okay. So um, the equation comes out to be, can anyone say? It is just simplification, nothing else. So it is 3v1 plus v1. It is 4v1 minus v2 equal to minus 6 times 12 is 72, right? So this is the second equation we have from node 1. Is it okay? Okay with everyone, right?
Okay, ma'am.
Now let's
Yes, ma'am.
apply. Now let's look at node 3. This v3. Now v3 here means, as I said in the previous, as I showed in node 1. So basically what it is, the voltage across this node with the reference is v3, right? Now in this branch there is no resistance connected, but a dependent voltage source is connected. So this v3 itself will be this 5ix. Why? Because there is no other element connected across this node, this node 3 and this reference node. So v3 will be equal to 5ix. Is this clear to everyone? Because the voltage, there is no element connected between this voltage source and between these two nodes. So this voltage itself will represent the node voltage at v3. Is everyone clear on this one? If not, you can ask.
Yes, ma'am.
Clear, right? Okay. So pen, yeah. So now we have another equation, that is v3 will be equal to 5ix, right? So uh, this is equation, let's say 3. Sorry, what is happening? Yeah, this is equation 3. Now we will look into this node 2, and we will apply KCL across node 2. Now when we apply KCL across node 2, uh, let's say, let's assume that this to be, since this is ix already given, let us assume two current across these two branches, right? So we will take this one to be I2 and this to be I3. So what will it be? Since there are three branches connected to this node, so Ix will be equal to I3 plus I2, right? Now what is Ix? We already have from equation 1, V1 minus V2 by 12. And what is I3? I3 is this voltage minus this voltage, because this is a resistance connected into this branch. Yeah. So yeah, so it will be this particular voltage minus this particular voltage divided by this resistance. So the voltage across the resistor is V2 minus, here it is 36 volt given here. So V2 minus 36 by the resistance 6. Clear to everyone?
Yes, ma'am.
Okay.
Yes, ma'am.
And I2 will be equal to,
V2 minus V3 by 15.
right, V2 minus V3 by 15. Now we already know what is V3. It is minus 5, sorry, 5ix, right? So v1 minus v2 by 12 equal to v2 minus 36 by 6 plus v2 minus 5ix by 15. Now we can replace ix by using equation 1, right? So it is v1 minus v2 by 12 equal to v2 minus 36 by 6 plus v2 minus 5 into ix is v1 minus v2 by 12 whole 15. Now this is the fourth equation. Now if you solve equation 4 and 2, you can get what is v1 and v2 because there are two unknowns and two equations. So everyone start solving this one and let me know what is v1 and v2. Can you quickly solve this one and let me know v1 and v2 when we are done? I hope you guys are solving.
Please give me 5 minutes, ma'am, because I am available in car and
So,
I'm going to home, ma'am.
sorry?
Please give me 5 minutes.
Okay. Others can solve, right? So it is 12v2 minus 5v1 minus, sorry, it will be plus 5v2 by 15 into 12. Can anyone tell me the simplified equation out of this? Yes, anyone apart from the person who was responding? Anyone else? Are you able to do or do you have any problems? You can let me know now. See, this is simple, solving the equation. You don't really need to do anything else. Okay. Did anyone come up with the values of V1 and V2? Dhananjay, are you there? Have you calculated V1 and V2? Okay. Um, Let me just give you the values of v1 and v2 then. You can solve the equation. Like this is pretty straightforward. You can solve the equation yourself. Let me find out. Wait. So, um, so the value of v1 that comes out to be is minus 14.85, and v2 comes out to be 12.6315, something like this. v1 and v2 comes out to be these two values. Now can anyone like calculate what is ix? You have v1 and v2, so you can use equation 1, right? So what is ix? Guys, are you able to do it? If you cannot understand anything, you can ask.
Minus 2.29 is correct.
Yes, tell me.
Minus 2.29.
Yes, ix comes out to be minus 2.29. Which option is correct? So the range that comes here in this particular range, so it comes in between this. So option B is correct, right? Everyone clear on this one? Can we move to the next problem? Because the next problem is actually a continuation of this problem.
Ma'am, question number 2 and 4.
Sorry?
Question number 2 and 4.
What do you want me to do? I did not understand. What do you want me to do?
Ma'am, week 3 assignment question number
Please,
2
ma'am,
and
wait. Oh, please explain them 12 questions. Any questions from them?
Uh, your voice is not audible very clearly. Can you repeat that? Someone, can you please write it in the chat box or like speak up?
Ma'am, explain all questions, ma'am.
I still am not able to understand. What did you say?
I think she's asking to solve assignment 3 questions number 3.
The previous assignment?
Yes, ma'am. Assignment number 3.
Okay, let me check. So you guys are able to access the previous assignment, right? Hmm. So this question, can you respond if you are asking this question? I mean, who was asking? Whoever was asking, can you please speak up, or I can proceed with the problems that we are supposed to solve? See, the current assignment that has been handed out, that one, like you will have to do it on your own. The previous assignment I can help you with, like just to get an idea of how to solve any the circuits or any other problems. Please let me know, or maybe type it in the chat box if you are unable to speak up. And in the meantime, we'll be moving to the next problem. Okay. So the next problem is actually a continuation of the previous problem. So it is the same circuit. Now that we know what is V1, we know V2, and we know the value of Ix. Ix is around 2.29, right? 2.29 ampere. And it is in negative. That means it is in this direction. It is minus 2.29 ampere. So in order to calculate the power that is consumed by this dependent voltage source, what do we need? We need the current in this branch and the voltage. So power can be calculated P equal to V into I, right? So voltage we can usually easily calculate it, right? V will be equal to minus 2.29 into 5, right?
Excuse me, ma'am.
Yes.
The question is to find total power in the circuit.
The question is to find the power in the dependent voltage source. This is the dependent voltage source because it has an like mm, this Ix term which is dependent on the current in this particular branch, right? So it is written here, determine the power associated with a dependent voltage source. So you have to calculate whether this particular dependent source is either absorbing power or giving out power, and how much is the total power. Is it okay?
Okay. Okay,
Yeah.
ma'am.
Yeah. So you know this V3 and V2, right? So you can calculate the current across this branch because V2 is known, right? V2 was uh, how much was V2? V2 was 12.6315. So we have this one 12.6315, and we know V3, right? V3 will be 5ix. So it is 5 into, where is the calculator? So it is 5 into 2.29. So it is 11.45 minus 11.45. So you can calculate this I, right? So then you can apply KCL at node 3 in order to compute what is I. So all the current, the 18 ampere current, the 24 ampere current, this particular current flows through this branch, right? So all these are coming into the branch, only I is coming out. So I will be equal to 18 plus 24 plus I. Let's say this is I dash. So I dash. And I dash is equal to V2 minus V3 by 15. So you have V2, you have V3, right? So you can calculate I dash and finally you can calculate I. So what is the value of I? What is the value of I? So it will be 12.6315 minus of minus 11.45. So it is plus 11.45 by 15. So it is 12.6315 divided by 15.
1.6 something.
1.6. So the power that is consumed by the voltage source will be I into V, right? So it is 1.6 into what is V? 11.45. Sorry. Did I go wrong anywhere?
Yes, ma'am. Yes, ma'am. We find only I dash, not I.
Oh, right, right. Sorry.
Okay, ma'am.
So, yeah, you're right. So, I will be equal to 18 plus 24 plus 1.6. So, plus 18 plus 24. It's 43.6. 43.6. So, this will be 43.6 into 11.45. Comes around to be around 499.2, something like that. So we have two options that that is within the range of our result. Now we have to find whether it is absorbing power or delivering power. So initially it was positive this side, negative this side, 5 ix. Now we find out that ix is negative, right? That means the direction of ix is different. So basically in reality when we compute it, the voltage will be, the positive side will be here and the negative side will be here if we take the correct direction of ix. So the actual voltage is positive terminal is this side and negative terminal is this side, right? And the current that we have assumed here, it comes out to be positive. Here I is positive, right? So that means current is flowing in this direction. That means it is entering through negative terminal and coming out of positive terminal, which means the source is delivering power, right? So the correct option will be option C.
Ma'am, but in the question we give plus is in upper direction and the minus in down direction.
Sorry? In the question,
Ma'am,
yeah, definitely. So in the question it is given as plus sign here and minus sign here, right? But your value of ix, it comes out to be minus something, isn't it? We have considered ix to be in this direction, but the value of ix is negative, right? In the previous question ix is negative, right? It is minus 2.29. That means what? Like this voltage will be minus 5 into ix minus 5 into 2.29. This will be the voltage. So it will be something minus x, right? Minus a negative voltage is there, but that is not
if
possible.
it is plus, it is absorbed.
Sorry?
If it is plus, it is absorbed.
Yeah, that you can like yeah, in the power, if it is a positive one, it will get like absorbed. If it is negative, it means it is delivering. That aside, if you simply look at the notation, like the direction of current also, you can figure it out in the same way.
Okay, ma'am.
Yeah. Everyone okay with this problem? If not, then we can move to the next one. Okay. Okay.
Excuse me, ma'am.
Yes.
Please show the previous slide.
Yes. Let me just check if anyone is there. Yeah. Yes. Tell me.
Ma'am, what's the V3 value? Minus 12.45
Sorry. Minus 12.
V3 value. V3 value.
Yes. V3.
Minus 11.45, ma'am.
Yes. 4 5.
Okay, ma'am. Thank you.
Yeah.
Go ahead, ma'am.
Okay. Okay. Then let's look at the third problem, in which a circuit is given and you have to find the power associated with a 10 volt source and 18 ampere current source. So there is this current source and this voltage source. You have to find the power that is associated with it. So like we calculated power in the previous one, it will be similar, right? So in order to compute power, what we need is, like, since we already have the voltage across, we have the voltage of the voltage source, so we need to find the current that is flowing through this branch, and in this case we have to find the voltage across this current source. Then we can use the power formula P equal to V into I and compute it, right? So how are we going to solve this now? Anyone has any suggestion? See, ultimately he will have to find either the node voltages or the branch currents, either of the two. So let us, so you have been taught the mesh analysis, right? And KVL. So let's use first, let's find like current, since these are like four different loops are given, let us like solve it using this loop equations, right? So let us assume this is I1, this to be I2, this one is I3, and in this loop I4 is flowing.
Excuse me, I have a small doubt.
Yes.
In the I1,
Hmm.
we are simply using the formula I is equal to V by R, 12 by 4 is I1. It's possible?
I mean, you will see. Uh, Here no, the voltage across this node and this node is given as 12 volt, right? And a 4 ohm resistance is connected across it. Now since we are calculating the if you apply KVL in this loop through this 4 ohm resistance, let me draw it here. Through this 4 ohm resistance, I1 is current, this much current is flowing in this way. Then again in the next loop you see I2 current is flowing, right? So I2 current is actually flowing this way. So it is not very straightforward that you calculate like 4 into I1 and equate it with this voltage, because through this branch, as per our assumption, I1 and I2 current are flowing, and they both are in the reverse direction. So the first equation that will come up
Okay,
is
ma'am. Okay, ma'am.
12
Two
equal to,
currents are acting.
right.
Okay, ma'am. Thank you, ma'am.
So okay, now let's apply like equations in each of the KVL in each of the loops. So for the first, let's assume this is loop 1. So first we can simplify this problem even further. So look at this particular branch. This particular branch, 18 ampere current is flowing in this direction, it is given in the question. Now what, from our assumption, I2 is flowing from A to O, right? So I2 is flowing from A to O, whereas I3 is flowing from O to A. So basically I3 is in the reverse direction. But this has to be equal to the total branch current, right? Otherwise, the KCL will not be applicable. So this will has to be equal to 18. This is one of the equation. The second assumption that you can do is this I4. I4 will also flow through this particular branch, but in the question it is given 24 ampere is given in the reverse direction. So I4 will be equal to minus 24 ampere, right? Now you can apply, like let us apply first in the small loop. I'll use a different color. Yeah. Now let's write the equation of this particular loop. So it will be 12 minus 4 into I1 minus I2 equal to 0, right? In this particular loop. So it will be 12 equal to 4 into I1 minus I2. So I1 minus I2 is equal to 3. This is your third equation. Now let us apply in the bigger loop. Like let us apply KVL across this particular loop. So when we apply KVL across this particular loop, so we first traverse from this is the same node. This is also 0, the reference node. So the first, this is through this 4 ohm resistance, I1 current is flowing through here and I2 current is in the reverse direction. So basically it is minus 4 I2 minus I1. Then through the 8 ohm resistance only I2 current is flowing, right? So minus 8 into I2. Then we come across this voltage source. Now this voltage source we are entering through the negative terminal. So let it be 10. Then we are coming across this 6 ohm resistance. In this 6 ohm resistance, it is the current that is flowing is I3 minus I4, right? Equal to 0. Now we already have the value of I4. So we can write this equation in terms of I1, I2 and I3. Is it okay till now? Is it okay for everyone?
Okay, ma'am.
Yeah. So let's
Clear.
simplify. So it is minus 4 I2 plus 4 I1 minus 8 I2 plus 10 minus 6 I3, and this is 6 I4, and we can replace I4 by minus 24, right? So in place of I4, let us write minus 24. So minus 24 into 6 is, so where's the calculator? 24 into 6, it is minus 144. So now you have this particular, we can further simplify this. So it is I2, so it is minus 12 I2, 4 I1 minus 6 I3 is equal to 144. So you divide it by 4, that will be the most simplified one. 2 I1 minus 6 I2 minus 3 I3 equal to, by 2 is 72. So you have this equation, uh, this is 3, sorry, this is 2. So you have 1, 2, 3, 3 equations and 3 unknown. So you can solve I1 and I2 and I3, right? So can you quickly solve this one? What are the values of I1 and I2 and I3? So uh, the way to solve this faster would be like substitute everything in terms of I3, because we need the branch current, right? Here through this voltage source I3 will be flowing. So just replace rest of the i's in terms of I3, like write I2 equal to I3 plus 18, and substitute I1 in terms of I1 will be equal to I2 plus 3, which in turn can be written as I3 plus 18 plus 3 is 21. So substitute I1 and I2 in equation 3 and you can solve for I3. Can you quickly solve this and tell me what is I3? So yeah, let me check the chat. Assignment 3, question number 2 and 4. Okay. Question number 2 and question number 4. Okay, we'll be solving it. So what is I3? This will be 2I3 plus 42 minus 6I3 minus 6 into 18. 6 into 18. It is 108. 72. So it is 9 minus 7 I3 equal to plus 72 minus 138. guess I'm doing something wrong here.
Minus 9, minus 12, minus 6 is correct.
Yeah. Then minus 6i minus 6i3. Sorry, could you repeat?
Minus 9, minus 12, minus 6.
Okay, you're talking about I1, I2, and I3.
Yes, ma'am.
I1 is minus. Sorry, could you repeat that?
Minus 9, minus 12, minus 6.
Uh, those are not the values that I actually got. Let me do it in a fresh page. That will be easier, I
Okay.
guess. So let me copy it to a different page. Okay. So 6 I3 minus I4. Okay. So let us get rid of this. We'll write it one equation at a time. Let's start it off from this equation here itself. So let us forget this. So I2 minus I1. So we can simply substitute from this equation 2, right? I2 minus I1 is 3. Sorry, I1 minus I2 is 3. So I2 minus I1 will be minus 3. So minus 3 into minus 4 will be 12. 12 minus 8i2 plus 10 minus 6i3, and this was 144, right? We have calculated by putting the value of I4 here as minus 24. We get it as 144 equal to 0. So now we have to replace either I2 or I3, right? So let's see. So I2 will be equal to 18 plus I3. So it is 12. So 12 plus 10 is 22 minus 8i2 minus 6. Let us replace I3 will be I2 minus 18 equal to 144. 6 into 18 is 6 into 18 is 108. Okay. 22 minus 8i2 minus 6i2 plus 108 equal to 144. So this will be 8 plus 6 is 14. So 14 I2 is 144 minus 108 plus 22. It is 130. So I2 is equal to 130 minus 14 is 14. 14 by 14. So if we take sorry, this will be minus 14, right? So we have taken the rest of it here. So it will be minus 14 by 14. So I2 will be equal to minus 1. So you can calculate now I3, right? Since I2 is minus 1. So if we put it here, minus 1 minus I3 equal to 18. So I3 is equal to minus 19. So what is the value of I3, that is the current that is flowing through this branch, is equal to minus 19. So what will be the power associated with this particular voltage source? It is P equal to V into I, right? So 19 into 10, that is 190. Now whether it is delivering or absorbing power. So I3, the direction is assumed from this to this side, but it comes out as negative. So the actual direction of the current is actually in the reverse direction, right? So the actual direction of current will be from this side to this side. Then it will be 19 ampere current. So the current is actually going inside the positive terminal. That means the source is absorbing the power. So let's find out. So this particular option is actually correct for the voltage source. Let us also verify for the current source if it comes out to be 360 watt absorbed. Now let's copy this to the next page. So the current, yeah. So we have the value of I3 to be minus 19, right? I3 is minus 19. I2 is equal to minus 1. And similarly, you can calculate I1. But let us assume this particular voltage to be V. Okay. Let us assume that the voltage across the current source is to be V. Now we apply KVL through this loop. Okay. Sorry. Not the bigger loop, the smaller one. Sorry. So we now apply KVL in this particular loop. So if we do that, across the 6 ohm resistor, what will be the current? So we have assumed the current through the 6 ohm resistor to be I3 minus I4, right? So I3 is minus 19. Minus 19 is flowing this way, and 24. So the current I4, so minus 24 is flowing through this way. So let us actually correct the current direction. So basically 19 ampere current is flowing through this way, and 24 ampere current is flowing through this way. So the net current that is flowing across this 6 ohm resistor is equal to 24 minus 19, that is 5 ohm in this particular direction. So this 6 ohm resistor, the branch current is 5 ampere, right? So if we apply KVL, so it will be V plus 10 minus 6 into the current. Branch current is 5 ampere. This will be equal to 0. So we can compute V equal to, this is 6 5s are 30 minus 10, that is 20 volt. So the voltage across this current source is 20 volt, and the current that is flowing is 18 ampere. So the power will be 18 into 20, that is 360. So the 360 now absorbed or delivered. So this is the positive terminal of the battery. The current is flowing inside the positive, not the battery, sorry. This is the positive side, this is the negative side. So current is flowing, going in through the positive side. So it is absorbing power. So the option D is the correct option. Everyone clear on this one? Is everyone able to follow it?
Yes, ma'am.
So we move to the next problem. Here you have been given a circuit and you have to find the value of K for which Dy
Yes, ma'am.
will be equal to 0.
Ma'am.
Yes? Is anyone trying to speak up?
Yes, ma'am. Yes, ma'am.
Yeah, let me know. What is it?
Ma'am, in the previous sem, P is equal to V into I, we discuss about it. But
Yeah.
in the I value, you put the I3. I'm right?
The I value here?
Ma'am, previous slide.
This one?
Yes, ma'am. In the
Yeah.
upper question, P is equal to V into I.
Yeah.
I is equal to 19.
I3 is equal to minus 19 ampere. Since we have taken this particular direction. Yes, tell me what you want to ask.
But I put in the plus 19 in that cell. P is equal to V into I. P is equal to 19 into 10.
Yeah, because
But
like,
I3 is minus 19.
so if we consider this particular direction of I3, that is from this side to this side, it comes out to be minus 19. That means in reality the current is actually flowing from this side to this side, right?
Yes, ma'am.
So this side will be 19. So the power will be 19 into 10, 190. Sorry, yeah, 190. Now, if we since this is the correct direction of current, so in this case, the branch current is flowing this way, right? So it is entering the positive terminal of the battery. That means the source is absorbing power. In the second lecture, I guess, sir has taught this one. Do you remember?
Ma'am, but 18 amps also going through it, ma'am.
18. No, look, there is through this node, like at this node, there will be current flowing here and here. So you cannot I mean you cannot say like since 19 ampere is current is coming through this particular branch, so 18 ampere is going here, you will find that 1 ampere current is flowing through this branch. So these two branch are connected like as shown here, like this entire loop is not independent, right? This is a node which is intersection of this particular 8 ohm resistance and a current source. So 18 ampere flows
It's
through
okay,
this
ma'am.
particular.
Why we consider I3 only for this?
Sorry? Why am I
Why we can?
considering only I3? Because,
Yeah.
yeah. So look into this. So from A to B, across this branch, this voltage source is connected. It is not connected across, let's say if you consider this O, across O, A, B, it is not connected. It is only connected across A and B. And at this A, another resistance comes up. So we cannot independently say that BA to O is a single loop. It is again node A is connected to this 8 ohm resistance, right? So we are only finding out the branch current. So I will draw this one here. So this is the sorry, this is only the 18 ampere current source. Okay, this is the voltage source, and this is another resistor connected across it, 8 ohm, and this is a node A. So if we apply KCL, there will be a current here, there will be a current here. We find that this current is 19 ampere. We find that this current, if you calculate it, it comes out to be 1 ampere, and this is 18 ampere. So power is what? V into I, that is, in this case, since it is the voltage source itself and the current that is flowing up to, in this particular branch, the branch is only from A to B. It is not up to O. Mind that. Because there is other elements connected from A to other nodes. If this particular
Okay, ma'am.
8 resistance would not have been there, then the entire 18 ohm current would have been flowing through this entire branch from B to A to O. But since this 8 ohm resistance is connected, so this node is again in in connection with this 8 ohm resistance, so we cannot simply consider this 18 ampere current, because it is actually KCL is has to be valid here, and we are applying the total current that is present in this particular branch A to B. Did you get it?
Yes, ma'am.
So
I mean,
yeah,
the exam calculator is allowed or not, ma'am?
calculator,
Yes, ma'am.
it is not allowed.
Okay, ma'am.
No, I'm asking, like, the rules will be given up to you. Like, I'm not sure whether it is allowed or not allowed. I guess it will be
Okay,
allowed.
ma'am.
I have to confirm with sir.
Okay.
Huh. So let us also like try this problem if it is okay with you all. So we have a circuit given here. The voltage, like we can apply KCL very easily in here, because they like this node voltage is given as Vy, and what will be the value of this node voltage? What is the node voltage value? It is the voltage across this node with the reference, right? So reference is at 0 volt, and across this resistance Vx voltage is given. Is there any other element connected here and here? No, it is not, right? So this entire voltage will be will be equal to the voltage drop across this resistor. So it will be
Ma'am,
equal
2
to,
ohm resistor is connected between them, ma'am.
sorry,
2 ohm resistor connected in between them, ma'am.
yes, and the voltage across this resistor is given, right?
Yes, ma'am.
So like there will be some current flowing across this 2 ohm resistor, and the voltage across this resistor is given. So here nothing is connected. I'm talking about this portion. Nothing else is connected, right? Only this voltage
Yes, ma'am.
drop.
Yes, ma'am.
So in this particular branch from A to O, the voltage drop will be only because of this resistor. And what is the voltage drop across resistor? Vx. So the node voltage at A will be Vx minus 0, right? Because this side it is 0 and this side it is Vx. There is nothing connected in between the resistor and node A,
Divided
right?
by 2, I'm right, ma'am?
Sorry?
Divided by 2, I'm right, ma'am?
Yeah. So this is actually Vx. At node A, the voltage is Vx. Now you can apply KCL at node A and node B, and you can compute. So we will start off like anyone wants to like try this one on their own, or do you want me to solve it? Okay, let me just write away the equations first. So at node A, if you apply KCL, so let us assume there is one current I1. Sorry, let me write it in the branch itself because we are applying KCL. So yeah. Um, so let us assume I1 current is flowing through here. Then this is I2 and this is I3. Current across this branch is already given. Let us say this is I4. So at node A, it will be uh, the voltage across this minus voltage across A by the resistance 1 ohm. So it will be 4 minus Vx, since the node voltage at A is x, by 1. It will, this is equal to I1. So basically if you apply KCL at node A, it will be I1 equal to I2 plus I3. Now I1 is equal to 4 minus Vx by 1. I2 will be Vx minus 0. So it will be Vx by the resistance 2. And I3 will be equal to Vx minus Vy by 2. Now it is already given Vy is equal to 0, right? Because not like we have to find the value of key for which Vy will be equal to 0. So let us assume this approximation in the start itself. That way the number of variables will be less. So let us simplify this. 4 minus Vx will be equal to Vx by 2 plus Vx by 2. So this is equal to Vx. So Vx will be equal to 2 volt, right? Now we apply again the KCL across node B. So it will be I3 will be equal to, sorry, I3 plus 3. Since I3 and 3 ampere current are both going inside the node, this will be equal to I4. Now what is I3? It is Vx minus Vy, which is equal to 0 by 2 plus 3, and I4 is equal to Vy minus the voltage here. So Vy is given as 0. The voltage in this particular will be equal to kVx, because across these and reference only this much voltage is there, this voltage source is there. So it will be 0 minus kVx, and the resistance here is 1 ohm. So this will be equal to I4. Now we have the value of Vx to be 2. So it is 2 by 2 plus 3 equal to minus kVx. So it will be 4 will be equal to minus kVx. Sorry, Vx also we have, it is 2. So k will be equal to minus 2, which is given in option B. Is it clear to everyone? Everyone still there?
Excuse me, ma'am.
Yes.
Why are we taking I3 plus 3 is equal to I4? How are we taking it?
Okay. So look, I'll use a different color. Huh. So in KCL, what happens? Summation of all the current that is either coming in or going out
Ma'am,
is
I got it, ma'am.
got it?
Got it, ma'am.
Okay. So anyone has any other questions? Otherwise we can move to the next one. So we have to calculate the power associated with the 3 ampere source. Uh, so we have to calculate the power associated with this source. So for that, what you need? The voltage. If we can calculate this particular voltage, we can easily calculate the power that is either delivered or consumed by this current load, right? It is the same
Yes,
like we
ma'am.
did earlier. So you can apply mesh, like I let us apply like three loop currents, I2 and I3. And when once we solve this, we can calculate, if once we know the I1 and I3, we can calculate the voltage drop across this resistance, when we can finally calculate the voltage across these two end, and then we can calculate the power, right? So what will it be? So let us first apply KVL in this. Suppose let's call this as loop. Let's call this as loop 1. This is loop 2, and this is loop 3. Okay. Now let's apply KVL across, let's say, loop 2. So it is, we are moving in this direction, in this particular direction. So it is, first we come across this 3 voltage source. So 3 minus, then 2 ohm resistance. I1 current is flowing down, I2 current is flowing up. So it is 2 into I2 minus I1, minus, then we come across this 3 ohm resistance. So I2 current is flowing from left to right, I3 current is flowing from right to left. So 3 into I2 minus I3, minus, only I2 current is flowing through here, so minus I2 into 1. So this will be one of the equation. So if you simplify this, it will come out to be, so 3 2 into 2 I1, 3 into 2 5 6. So it will be 6 I2. You bring the I2 on that side, so 6 I2 minus 3 I3 will be equal to, so I2 I3 I1. Now one thing to note here, that in this loop I1 current is flowing across it. So in this, like through this current source, I1 current is actually flowing, which is equal to 3 ampere, because it is already given in the question. So I1 will be equal to 3 ampere. So you can write I in place of I1 as 3. So it will be, huh, so 3 to the 6 plus it will be 9. So 2I2 minus I3 will be equal to 3. This is one of your equations. Then apply KVL in loop 2. Loop 3. So in this particular resistance, it will be like I1 current is flowing from left to right, I3 is flowing from right to left. So accordingly, we will write KVL in loop 3 as, so first the 2 ohm resistance, so minus 2 into I3 minus I1, and we know I1 is 3 ampere, right? So then minus 7 into, only I3 current is flowing in that loop, so only I3 minus 3 into I3 minus I2. So let us simplify this, and the equation comes out to be uh, 12, let me just write it, 12 I3 minus 3 I2 equal to 6. So this is your second calculation. Since we are running short of time, you just have to solve this equation 1 and 2 and find out I1 and I2, right? I1, I2. I3 we already have it. I1 is equal to 3 we already have. I2 and I3 you will have to find out. Let me just look at the, like, all you have to do is solve 1 and 2. So uh, let me see what is the value of I2 will be equal to 2 and I3 will be equal to 1 ampere. So you just solve this equation, you will be able to calculate this. Now what you have to do is, you have this, the current that is flowing across this resistor and this resistor. All of it will be known because you have I1, I2 and I3. So then you have to apply KVL. Let me change the color. In order to find this voltage, you apply KVL across this particular loop. So what? Let us assume that the voltage across this current source is V. So if you apply KVL in loop 1 now, so it will be equal to, let the voltage be V into 1 minus I1 into I1. Then it will be minus 2 into I1 minus I3, because this resistor, and then we come across this 2 ohm resistor, so it will be 2 into I1 minus I2, and finally this 3 there is a voltage of 3 volt, so it will be minus 3 equal to 0. So V will be equal to, I1 is given as 3, so it will be 3 plus 2 into I1 minus I3. I1 minus I3. 3 minus 1 is 2. Again 2 minus 2 into I1 minus I2. I1 minus I2 is 1 plus 3.
Excuse me, ma'am.
Yes.
Ma'am, why are we putting 3 as minus 3?
Uh, which one?
The last one.
So minus 3.
Yes, ma'am. Why?
So the thing is, like, here I am assuming if we are entering through the negative terminal, we are putting a positive. See, the notation of the voltage should be uniform. So in this case, you see this is minus and this is plus, right? We are assuming the voltage, like a voltage to be like this. So we are entering through the negative terminal. So we are putting a positive V here. Had we taken this one negative V, this particular, like when we come across this positive terminal, we would have put in plus 3, but we are taking the negative, like, see, you can take the notation either way. Like, if you are to consider, like, if you are entering the positive terminal, if you take a plus 3 voltage, then in this particular V you have to take this as minus V, and along the direction of current will be positive, because
Ma'am,
voltage
the
drop.
loop, because the loop is flowing to the minus 2 plus, so we put it minus 3, I'm right?
So look, let me just give you an example. So let us assume this is a voltage V, this is a resistance R, and a current I is flowing through it. Just apply KVL across it. So according to what you are following the notation, it is minus V plus I into R will be equal to 0, right? Along the direction of the current, along the voltage drop, because the voltage drop will be across the resistor. So it will be V equal to IR, right? But if we take the reverse direction, that is, if you are entering through the negative voltage, so we take that one as V instead of minus V, and along the direction of the current, it will be minus IR, right? Are you getting the difference? Like it is the same thing, only you are following notation of what
I
you
mean,
have
the point
said.
of view, uh, but we're putting in KVL at 2.
Hmm. So if let's say you are applying KVL here, okay, in this particular which I have highlighted using blue. So how will you write it? It will be minus V, right? Since you are entering through the negative terminal. So minus V plus I1 into 1 ohm resistance, right? Plus 2 into I1 minus I3. Then 2 into I1 minus I2 plus 3 equal to 0. This is what would be what you must have written, right? Are you getting it?
Yes, ma'am, got it, ma'am.
Okay, this is the same thing that I have only you like if you take this on the other hand of the 0, it will be the same equations. Did you get it?
Yes, ma'am, I got it, ma'am.
So it is basically the notation that you are following.
Yes,
So
ma'am. The following of the direction change also change.
right. So B will be equal to 3 plus 4 minus 2 plus 3. So it is 6 plus 10. So it is 8. So we. Sorry. Am I doing everything correct? Sorry, this will be plus, right? So you're taking everything on the other side. So it will be plus I1 minus I2 is 1. Yeah. So it will be 3 plus 3, 6 plus 4, 10, 12. Sorry. This will be 12. V will be equal to 12. So the voltage across this particular current source is 12 volt. And the current source is giving out 3 ampere. So 3 into 12, 36 watt. Now is it delivering power or giving power? So the current is coming out of the positive side. So the voltage drop is positive this side and negative this side. And current is coming out of the positive side. So it is delivering power. So the correct option is option C. Everyone is getting it? Is it okay with everyone?
Yes, ma'am. Yes, ma'am.
Okay. Then let's move to the sixth problem. So here,
Ma'am,
yes.
if I pick one sum and do it individually,
Huh?
but I have a little confusion that while we applying KVL and KCL and mesh and node, how we can identify that this sum is for KVL, this sum is for nodes.
So there is no such hard and fast rule regarding it. It will come like it will come to you with experience as you keep solving problems. So mostly, if you see a lot of uh, you know parallelly connected loops, so if your like circuit kind of looks like something connected again, then something is connected here, then something is connected here, it is easier to use KCL. Then if there are multiple like these two resistance again connected across this particular resistance, if it comes up like that, then it is easier to use like mesh currents and compute the mesh currents and solve the problem. Like in both ways you will be able to solve it. Using only KCL you will be able to solve it, using only KVL you will be able to solve it. but the thing is how much time it requires to solve it, that is important. So mostly in parallelly connected circuits, like where all the branches, most of the branches are connected in parallel, you use KCL. In the other cases you can use mesh or like mesh, from which you can use KVL and finally solve it. It's like you will, it is a general intuition, you will like learn it as you solve more and more circuits.
By practicing, you got it, game, right, ma'am?
Sorry.
By practicing, I
Yeah,
get
yeah,
it.
definitely, definitely. So like
Okay, ma'am, thank you.
I'll show for this particular, suppose if you consider like you tell me what do you think will be best to solve here. Like you have to find this resistance. So what will be the,
KCL.
yes, because if you just find this node voltage, then you can easily calculate the resistance here because you already have the current. So KCL will be the easiest option here. So let us just like let's say this is I1, this is I2, and the current here it is given. So if you apply KCL at node suppose A, so it will be I1 plus I2 plus 10 equal to 0, right? And yeah, so what now you apply like the node voltages, it is given here 24, this is unknown. So you have to find, what you have to find is this V voltage, right? So it will be V minus I1 is flowing through this one. So V minus 24 by 1 mega ohm. Now, if you see like V is equal to I into R, right? So if this is in micro, which means 10 to the power minus 6, and R is in mega unit, so it is 10 to the power plus 6. So voltage will be in volt only. The unit will be adjusted according to current and resistance. So so we can simply write V minus 24 by 1, plus for I2 it will be V minus minus of 12 by 1 plus 10 will be equal to 0. So it is V minus 24 plus V plus 12 plus 10 will be equal to 0. So 2V will be equal to 24 minus 22, that is equal to 2V will be equal to 1. So now you can easily calculate because your branch current is given and V equal to I into R. So V will be equal to, this is the reference voltage, so it will be 0. So this will be 1 minus 0 by current is given as 10. So current is given is microampere, this is volt, and resistance therefore will be in mega ohm. So it will be 1 by 10 mega ohm. Now options are given in kilo ohm. So mega ohm means 10 to the power 6, kilo means 10 to the power 3. So if we simply convert this unit into kilo ohm, it will be 10 to the power 3 by 10 kilo ohm, which is equal to 100 kilo ohm, which is equal to option C.
Ma'am,
Yes.
you say that 10 power minus 6 in the minus 6, minus 12 volt, 10 power plus 6 in the 24 volt. Am I right?
No, no. What I'm saying is like suppose how do, so this unit is in mega ohm, right? However,
Yes,
the
ma'am.
current here is in microampere. So writing straightforward as 1, is it wise in this particular equation? So let's check. So voltage is in volt. This is in mega ohm. If we write it in ohm, it is 10 to the power minus 6, right? If we take this up, it will be 10 to the power 6. Sorry, mega ohm is 10 to the power plus 6. So this will go 10 to the power minus 6. This 10 microampere, since all the dimension of all the three should be same, right? So it is actually, if we write it simply 1, the dimensions are satisfied because this is in mega ohm. So if you take 10 to the power minus 10 to the power plus 6 up, it is 10 to the power minus 6. So this particular is also in microampere, this is also in microampere. I was just trying to show like, otherwise we have to write here 10 to the power like minus 6, and again here 10, sorry, 10 to the power 6 and 10 to the power minus 6 here, and it will be adjusted. So for KVL equation, if we write it simply like this, it will be fine, because the denominator is in my mega ohm, and the numerator here, like the current is in microampere. Am I clear? Otherwise, let me just show you like
Okay,
this.
ma'am.
V minus 24 by 10 to the power 6. The, if we write it in terms of, this will be in voltage, this is in resistance, ohm, so it will be in ampere. If we maintain the unit of ampere here, so it will be V minus of minus 12 by 10 to the power 6, and this will plus 10 to the power minus 6, since it is micro ampere given. So if we simplify this, if we take this one up, so it will be 10 V minus 24 into 10 to the power minus 6 plus V plus 12 into 10 to the power, sorry, 10 to the power minus 6 plus 10 to the power minus 6. If we take out 10 to the power minus 6 common, you will arrive at this particular equation, right? Are you
Yes,
getting?
ma'am. Got it, ma'am. Got it, ma'am.
So the option is option C. So, like, I have one more problem. Do you wish me to wish to continue, or should we stop here? It is like past 8:30, so I'm just asking, like, should we stop here, or do you want to finish off another problem and then conclude? Sorry, where is? So I see only 6 people here. Or maybe we can stop here. I'll just discuss the next problem over and then we'll leave. So in the seventh question, you have to calculate the current supplied by the 10-volt battery. So the 10-volt battery is here. You have to find the branch current here. So you can either, like, use mesh analysis, assume two current, and then solve for I1 and I2. So whatever this I1 current will be actually flowing through this branch. So if you solve for I1, you can like get the correct option in this case. So you guys solve this one out. If you face any problem, we can maybe discuss in the next interaction session. Until then, we can stop here. So if anyone has anything specific to ask, you can ask. Otherwise, we can stop for the day. Okay, thank you all.